Hi, this is Dr. Thomas, math instructor at Lawson State Community College, and in this video I'm going to show you how to add and subtract rational expressions. So you must remember that you need an LCD, the least common denominator, in order to add and subtract fractions. So if you can remember that, you'll be set, because that's all you need. You need the same denominator. Okay, so the denominators must match to add and subtract fractions. Okay, so let's start by adding a very simple fraction, just dealing with numbers. So let's say if we had 3/4 plus 5/12. Now this is an addition problem, but we're dealing with fractions. So because we're dealing with fractions, we must come up with a common denominator. We call it the least common denominator. So basically we want to find a number that both 4 and 12 can go into. So 12 cannot go into 4 because 4 is lower than 12. But I see that 4 can go into 12. So 12 is the least common denominator. So in order to get these denominators to be the same, I only need to multiply 4 times 3. And to do this legally, you must not only multiply the denominator times 3, but you have to multiply the numerator times 3 as well. Now what makes this legal is that I just basically multiply 3/4 times 3 divided by 3. 3 divided by 3 is really 1. So that's why multiplying the numerator and denominator by the same thing is legal, because anytime you're dividing or multiplying the denominator and numerator by the same number, you're really just multiplying times 1. Okay, so what we have now is the equivalent fraction for 3/4 is now 9/12, because 3 times 3 is 9 and 4 times 3 is 12. So 9/12 is equivalent to 3/4 if we reduced it, plus 5/12. Now since both of these fractions have the same denominator, the rule is you keep the denominator the same. Do not add them. Do not subtract them. You keep the denominator the same. But you will combine the numerator. So combine the numerators. So what we have is 9 plus 5, which is 14. Now looking at this, it looks as if we can reduce this. So this is simplifying the fraction now. So I noticed that 14 and 12 has a common factor, and that common factor is 2, and we must get rid of that common factor. And usually we divide these numbers by that common factor. So we usually put a line through 14 and say 2 goes in 14 7 times, 2 goes in 12 6 times. So the answer is 7/6. Normally in Math 100 we keep the fraction as an improper fraction, and we do not change this improper fraction to a mixed number. Okay, let's try subtracting rational expressions. So now we have variables in the denominator. Now this concept still applies. We still are trying to get the same denominator. Now Right now we have 2n and we have 4m. How can we get both of these denominators to be the same? So it looks as if all I need to get this to be a 4 over here is to multiply this times 2. And both of my numbers will be the same. And in this denominator on the left, I have an n, but I don't have an n over here on the right. And I have a m on the right, but I don't have an m over here on the left. So all I need to do is figure out what I need on both sides so that my denominators are the same. So it looks as if my LCD is 4, because I can get both of these numbers to be 4, and I need an m on this left side and I need an n on the right side, and then both my denominators will be 4mn. So in order to get 2n to be 4mn, I gotta see what I can multiply times 2n to get that. And all I need is a 2 and an m to get this LCD 4mn. And because I multiplied it times the denominator, the only legal way to do that is to also multiply the numerator times 2m as well. And then on this side, I have the 4 already, right? I have the m already, but I'm missing the n. So I only need to multiply the numerator and denominator by n. Okay, let's see what we have. 5m times 2m is 10m squared over 2n times 2m, and of course we're hoping that it's 4mn, or else we'll have to start back over. But it is 4mn minus 3n times n is 3n squared over 4mn. Therefore, we can combine this into one fraction. Now, since the denominators are the same, we can combine the numerators. So 10m squared minus 3n squared divided by 4mn. Look back at your answers to see if you can simplify your final answer any further. And you can't factor the numerator, so you can't cancel anything out. Therefore, this is the answer. Okay, let's try 5 over 12a squared b minus 1 over 6ab. We're subtracting a rational expression, so anytime we're adding or subtracting fractions, we must come up with the LCD. Now I have 12 and 6 out of the numbers. I can get 6 to be 12, so I know 12 is a part of my LCD. I have a squared over here and I have an a over here. So the only thing I need to do to get those to look alike is just multiply the right denominator by another a to get a squared. So I know a squared is a part of my LCD, and I already have a b on both sides. So b is a part of my LCD. Now, what do I need to multiply the left side to get 12a squared b? Nothing, because it's already 12a squared b. But I am missing some factors over here in this denominator, 6ab. So, what do I need to multiply 6ab to get 12a squared b? I definitely need to multiply times 2 to get that 12. And another a. So therefore, top and bottom by the same factor. Therefore, we have 5 over 12a squared b minus 2a over 12a squared b. And we must combine it into one fraction. 5 minus 2a. Erase that. 5 minus 2a over 12a squared b. Can't factor that, so this is the answer. Okay, let's try 1 over x plus 2 over x squared. Pretty simple. So what is the LCD? I can't get x squared to be x, but I can just multiply x times x to get x squared. So the LCD is x squared. So basically we're looking at the higher powers, not the lower powers. So in order to get both of the denominators to be x squared, I only need to multiply this fraction by x over x. Okay, so now 1 times x is x over x squared plus 2 over x squared. This will allow me to write this as one fraction, x plus 2 over x squared. No, you cannot cancel this term with this factor. You can only cancel factors with factors, not part of a factor with a factor. Okay? Okay, let's try 9x over x minus y minus 9y over x minus y. So we're subtracting fractions, and if you notice, the denominators are already the same, so no need to find the LCD. The LCD is already given to us. It's x minus y. We only need to combine the numerators. So we have 9x minus 9y. Now, notice that in the numerator we can factor. How can we factor 9x minus 9y? Well, the GCF is 9. So we need to take out a 9 and see what factor remains. So 9 times what is 9x? X. 9 times what is minus 9y? It's minus y over x minus y. So here notice that we have the same factor that we can cancel out. So we can cancel x minus y with x minus y, and that leaves us the answer 9. Okay, so we have x over x plus 2 plus 1 over x. Let's see what the LCD is. Now, notice that I cannot multiply anything times x to give me x plus 2. It is its own distinct factor here. So don't fight it. The factors are x and the x plus 2 multiplied times itself. Okay, so the factors for the LCD are both of these factors, because you can't multiply anything times x to get x plus 2. You can't multiply anything times x to get x plus 2. Therefore, the LCD contains both of these distinct factors. So how do I get x plus 2 to look like x times x plus 2? I'm only missing the x here. Okay, so we will multiply top and bottom by x, and it really doesn't matter if you put the x behind the x plus 2 or in front of it. Multiplication is commutative. Therefore, x plus 2 times x is the same thing as x times x plus 2. Alright, let's look over here on the right side. We have the x, but we're missing the x plus 2 on this side. So we'll multiply numerator and denominator by that same factor. Let's see what we have. We have x squared over x times x plus 2 plus 1 times everything over here. It's x plus 2 times x plus 2. Therefore, we can now combine the numerators, x squared plus x plus 2 divided by x times x plus 2. I know it seems tempting to try to cancel this x plus 2 here with this x plus 2, But notice that x plus 2 is not a factor. It's actually a part of the trinomial x squared plus x plus 2, and you cannot cancel terms with a factor. Okay? And the reason why you know this is a factor, it has a parenthesis around it and is being multiplied times x. But here we have addition symbols, and so this x plus 2 is actually being added to the x squared. So you cannot separate x squared from x plus 2. Now, what you can do here is figure out if you can factor the numerator, x squared plus x plus 2. The leading coefficient is 1, so we only really need to try to figure out the factors of 2 that'll give us a positive 1. So factors of 2 that give us a positive 1. Are there factors of 2 that give you a positive 1? No. Therefore, this is your final answer. Okay, let's try x divided by x plus 2 minus 4x over x minus 6. Now here you're going to have to be very careful because this is a subtraction symbol here. And let me erase this so you can see that it's on the same level. The subtraction symbol is right in the middle. Alright, and normally you have to be very careful. Alright, so let me put caution here. This is a subtraction problem. Alright, so the LCD here is what? Now I can't multiply anything times x plus 2 to get x minus 6, and I can't multiply anything times x minus 6 to get x plus 2, so don't fight it. The LCD contains both of these distinct factors. So the LCD is x plus 2 times x minus 6. Okay, so we look at the denominator to the left and we say, what is x plus 2 missing that's in the LCD? It's missing the x minus 6. So since these are binomials, I'm going to put both in parentheses, x minus 6, and because I multiplied it down here, I must multiply the same thing in the numerator. What am I missing over here? I'm missing the x plus 2. So I multiply the numerator by the same factor. So now let's simplify. So we have x times x minus 6, and I'm going to go ahead and just write one LCD here so we don't have to rewrite this all the way back over. Since both of my denominators are the same, I can combine the numerators. So x times x minus 6, distribute that, we get x squared minus 6x. Now we must be careful because we have a subtraction symbol. So this negative really means to distribute through. Okay, so we have not only 4x times x, but negative 4x times x. It's really, this negative goes along with the 4x. So it's minus 4x squared. What else? Minus 8x. Okay, and why is it minus? Negative times a positive is negative. Okay, now we need to combine like terms. X squared and negative 4x squared. Those are like terms. That gives us negative 3x squared. Then we have a negative 6x and minus 8x. Same sign. So we're going to add. So negative 14x. Now, can we factor the numerator? It looks like we can. Alright, it looks like we can factor the numerator. We can take out an x or a negative x, and that gives us 3x plus 14. Why is it plus? Because that if I took out a negative, then that negative times that positive will give me back this negative here. Alright, and put the denominator down, and we see that it didn't affect the problem really, because nothing canceled. But you always need to make sure, you need to factor to make sure that there is no common factor on the outside here with something at the bottom. There's not, but you always need to check. Perhaps one more. Let's make one up. 4 over y squared minus 16 plus 3 over y squared minus 8y plus 16. Alright, now recall the steps that we went over earlier, and the first step was factor the denominators if applicable or applicable. Okay, and in this case you can factor the denominators, and the reason why we want to factor the denominators is we're trying to basically tear it apart so we can figure out what's in common with both of these denominators. Right now we really can't tell, but if we factor both, we may see something that's in common, so we can figure out what the LCD is. So if we factor y squared minus 16, it is a difference in squares, so the factors are y plus 4, y minus 4. To the right, we have a trinomial. We need to figure out factors of 16. Then if you add them together, will give you negative 8. What are those factors? Y minus 4, y minus 4. Now, let's see what the LCD is. LCD. So look on the left side. We have a y plus 4. So I definitely need to get a y plus 4 on the right side. So that's a part of my LCD, since I got a y plus 4 factor. Then I got a y minus 4. But then I realized I have a y minus 4 on this side. Not only do I have a y minus 4, I have 2 of them. Now how can I get both of these denominators to look the same? I need a y plus 4 in both of them. But guess what? I need 2 y minus 4s in both of them. Because I have 2 on this side. It's not going to look the same if I only had 1 y minus 4 on this side. They're not the exact match. Okay, since it's 2 on this side, I actually need 2 y minus 4s on this side. So the LCD is y plus 4 times y minus 4 y minus 4 times y minus 4, or y plus 4 times, if I want to condense this, it's the same thing as y minus 4 squared. Okay, so again, on the left side, if we look at the LCD here, what am I missing? I am missing another y minus 4. So we must multiply this side by another y minus 4. And on this side, I have the 2 y minus 4s, but I'm missing the y plus 4. So I need to multiply that side by y plus 4. So y plus 4 times y minus 4 times y minus 4, or you can just say y minus 4 squared. Alright, so 4 times y minus 4 is 4y minus 16. Then distribute over here, we have plus 3y plus 12, and 4y plus 3y here, 7y. Then we have a negative 16 and 12, negative 4 over y plus 4 times y minus 4 squared. Alright, 1 for the road. Let's say we had 3 over x plus 2 plus, or let's put a minus. Let's put a minus here. Minus 2 over 2x plus 4. Now, what should you be cautious about? There's a minus sign here. So always exercise caution when there is a minus sign in the middle. First thing you need to do, if applicable, factor the denominators first. So can't factor x plus 2 is already simplified, but on the right side, can we factor 2x plus 4? Can we factor that? Of course we can. How? Well, the GCF is 2, right? So take a 2 out, and we have x plus 2. So what is the LCD? Well, it can't just be x plus 2, right? It can't just be that, because there's a 2 that's showing up over here. So the LCD is not only x plus 2, but it's 2 times x plus 2. That's how we're going to get both of them to look alike. If that has a 2 on the right side, I got to make sure I multiply the left side by 2 as well. So I only need to really multiply this side by 2. I'm going to go ahead and put it in the front. Doesn't really matter. You put it in the front or the back. Okay? So I can put it in. It doesn't matter as long as I have a 2 in the numerator and a 2 in the denominator. Okay, now, are my denominators the same? Yes. So we can proceed by combining and simplifying the numerator. So I'm going to write 2 times x plus 2 in the denominator. And what do we have in the numerator? 3 times 2, which is 6, minus 2. Alright, 6 minus 2 is 4 over 2 times x plus 2. Now, am I finished? Actually, no. So see this 2 hanging out here and this 4? You can actually simplify that 4 and that 2. So what number can go into 2 and 4? 2, of course. So 2 can go in 4 2 times, 2 go in 2 1 times. Therefore, the answer is, drum roll, 2 over x plus 2. No, you cannot cancel the 2's out here. You cannot cancel this term with this number up here. You can only cancel factors with factors. Okay, this concludes this video on adding and subtracting rational expressions. I believe that it's going to help you out a whole lot.